I've had a few questions lately about my foundry, so I thought I'd give you a quick tour of it. As you can see, it just looks like a quite unsuspecting residential garden shed. That is until you open the doors and start looking a little more closely. The heart of any foundry is, of course, its furnace. This little beastie's made from the outer shell of an old water heater I found on the scrap. Pretty heavily modified, of course. It's got about 50 millimeters, so 2 inches of calcium silicate insulation, solid insulation that is, which is very sort of a light material. Then there's about 25 millimeters or an inch of kale wool lining, and then the hot face is a proper industrial refractory designed for 3000 Fahrenheit or whatever that is in Celsius, and that's about, the hot face is about 12-13 millimeters, about half an inch thick. The furnace bore is 25 centimeters or 10 inches, and the depth down to the plinth is about 29 centimeters, so just under a foot. I sized it to be able to just fit a A20 crucible in there. It's probably not enough airspace for good combustion at that size, so it may not be able to melt iron to that volume, but should be able to do aluminium fine. So the next thing on the list is, of course, burners. I've made 3 burners so far. This is the smallest. This one's like a 3/4 inch water pipe. It's just a Bunsen burner. Has an air valve, a MIG torch nozzle in there, and just connects to a normal gas bottle with a flare, of course, to stabilize it when it's not used in the furnace. I quite often use this for bigger brazing jobs or heating jobs, and in the furnace I use it turned right down to burn out the PLA if I do a lost PLA casting. So next up is a bigger Bunsen burner. This one's sort of roughly copied off a design I saw on the internet. You can see it's got a rather stiff air valve. But once again, there's a MIG jet in there, and you can adjust how deep in the jet is to optimize it. Don't have a flare on this because I only ever use it in the furnace. This one's used for preheating. I generally run this until the walls of the furnace are starting to glow red before I switch over to oil. So we start with a tank made out of an old fire extinguisher. I added a coupling for an air hose to the top of it and a valve, so I can just fill it with a mix of mostly waste oil with a bit of diesel to help it ignite easier, and then run the air line to the top, open the valve, and that pressurizes it, sending the oil down the tube to the actual burner itself. So here's the main part of the oil burner. Airflow is provided by a 70-watt induction motor driving a squirrel cage blower. It's actually quite nice because one, it's very quiet, and 2, when you first turn it on, it takes quite a while to get up to speed. So the airflow comes on quite sort of slowly and in a controlled way. Oil's coming down the tube. We've got a needle valve which I turned on the lathe to control the actual oil volume, and then a shut-off valve to turn it on or off. In here there's just a copper tube which comes to about here, and then as a hotshot style burner, the oil just drops out of the tube, gets caught in the airflow, and you really need the preheated furnace to vaporize the oil and make the system work. You can't run into a cold furnace. So the Crucible Collection consists of 2 A5s, an A10, an A15 and an A20. They're all clay graphite crucibles made by Mammoth in Germany. As you can see, the A5 I use for iron castings probably starting to get thinnest. This one I normally only use for aluminium. I've done one brass casting in it, but the one for aluminium seems to last for ages. Yeah, I haven't actually used the A15 or the A20 yet. Yeah, I guess I haven't even made the pouring tongs or lifting tongs or anything for them yet. That's something I'll do once I've got a need for a casting job. For the little A5s, I've got these combined lifting and pouring tongs which I made up. They seem to work quite well. Obviously they never get terribly heavy, maximum of about 5 kilograms of metal. For the bigger crucibles, separate lifting tongs and pouring shank will be used. This way should be hopefully a lot safer. So my moulding bench has a large storage box below it which has the sand in it, and then the bench above it's got a big hole in the middle with where I just put a moulding board on top, and then all the extra sand I just get to just push that through the hole, falls back into the sandbox, so that's quite convenient. I was asked about the mould I used for the pattern I used for my Bolly faceplate. This is it here. It was my first attempt at a match plate mould. Totally unnecessary for this job. I just wanted to give it a try. The pattern itself was 3D printed in 3 parts. It's about 210 millimeters across, and I use a baked sand core for the hole in the middle. So it just goes on the pattern like this, with in the flask like this. Flask lines both sides. You ram one side, flip it, ram the other, cut some gates. I'm not going to do a video on casting because I think, you know, the best ones on the internet are already done. Guys like Olfoundryman, you know, who are actual professionals. You really need to see their channels. They're the guys that know how to do this stuff. Bob from the CNC forum's been bugging me for months to show off my sand muller, so I guess it's about time. This is the steel innards of that old water tank. Then the one where I used the outer shell to make the furnace. Well, the inner shell was used for the muller. I designed the stand so that a bucket can fit straight underneath it, and there's a dump door here. One of the big advantages of a muller, in addition to being able to easily do the recondition the sand without any effort, is it gives you a place to actually dump hot sand. You know, when you come straight off an iron casting especially, the sand can be so hot you can't put it in anything plastic, you can't put it on a sheet to stomp mull it. It needs to cool down. This way I can just dump it straight into the muller, and everything inside the muller is iron, nothing's going to happen to it. Put in a bit of water, run it, mull it. By the time the sand's finished, it's much cooler. This muller wasn't so much designed, it was more sort of thrown together with scrap and odds and ends. Some just sort of heavy drops of steel with a couple of bearings in them. There's kind of a hubcap on here to keep the sand out of the bearing. You've got some seals there holding onto a shaft. The whole thing just pivots on an arm so that it can't bind up. Inside here is the shaft, also with a couple of bearings. I used a 10mm steel plate which I got laser cut as the base for the muller, so it's pretty abrasion resistant. Cut out the arc for the dump valve, and then on this side I've just got a sort of a half-assed collection of pieces of bent sheet metal to sort of push the sand around and try and direct it back into the path of the wheel. It certainly doesn't work as well as the much bigger, flatter mullers like Untitled have, but it fits the space I've got available. And even if it doesn't work that effectively, I normally only put in a maximum of 1/2 of a flask at a time. I can't put in a huge volume of sand. But it certainly sure as hell beats doing it by hand, and gets the job done. So it's driven by a little half horsepower 3-phase induction motor, which runs through a gearbox with a 30 RPM output, and that just goes then straight onto the main shaft of the muller. Here in this control box there's a little half horsepower variable frequency drive or inverter with on, off and emergency stop buttons. Still got a big lump in there that's blocking it just a sec. Big lump in there that's kind of blocking it. Sometimes you need to get in and give it a bit of help. Probably need to adjust the sheet metal a bit so it doesn't scrape on the edges and make such a horrible noise. Million times easier than stomp mulling it on an old sheet or any other way of doing it by hand. Works quite well. This sand might still be just a little bit dry, but yeah, muller seems to work quite well. There was a question on the German Zerspannungsbote forum what sort of scrap I've been using for my iron castings. As you can see, it's just some general scrap. This is an old pump. There's some brake disc there. This is something I already cast. This was my first attempt at a faceplate. There was way too many defects in that. But yeah, I don't use any ferrosilica because I can't get it. If anyone knows of a source of ferrosilicate in Europe in small amounts, I'd appreciate to find out. But so far I've just done it with pure cast iron scrap. My aluminium scrap bucket's getting pretty low. I'm probably going to have to go and get a couple of old damaged alloy wheels or something. Although I think in the basement I've got an old cylinder head I need to chop up as well, so that's going to be a bit of a pain. My brass scrap bucket's full of all the old plumbing fittings from when I modified my house. Don't really like using brass so much because the zinc burns off. I prefer to use bronze, so I've got a big box of old copper pipes in the basement which I use, and I just add a bit of pewter to them by just used pewter cups and stuff from the internet, and add that to make some bronze. So this is the first successful iron casting I've ever done. I've tried iron 6 times. This was the 6th attempt. For a variety of reasons, I had a lot of different failures. This is the first one I consider to be a success. As you can see, when I started machining the boss for the spindle, I do have an inclusion here, but it's still cut quite nicely. I don't think it's going to be a problem. Otherwise, there's a few little voids there and there. No great issue. The surface finish is pretty horrible because I didn't put any coal in the facing sand. I put a boss on the back to hold it in the forged chuck to machine these features. I'll then set it up on the. I'll cut that off with an angle grind. Set that up on the mill. I'll cut the spindle thread using thread milling, and then remount it as a faceplate, and finally turn the outside and the main face once it's mounted on the spindle. Anyway, that's the end of this video. thanks for watching to the end. If you like my videos, I'd appreciate a like or a subscribe. Till next time, see you later.